Okay, let's look at another example of tangent line problem. Right, so we want to find an equation of a tangent line to the curve of this equation at 4, 2. Right, so let's do that. Right, so we already know that x1 is 4 and y1 is 2. So we got the point. So we need to find the derivative so that we can find the slope of the tangent line. Alright, so let's take the derivative. Actually, before we take the derivative, I don't like square root, so I'm going to rewrite it this way. So you will have, right, 6 is 6, but square root I don't like, so I'm going to write it as a quantity y cubed plus 1. And raise it to the square root is equivalent to 1/2 power, right? So we have that, and the rest looks okay. So I'm going to just keep those as it is, as they are. So you have x to the 3/2 power minus 2 is equal to 0. Alright, so let's take the derivative. So we're going to take the derivative with respect to x. So we're going to take the derivative with respect to x. Alright, so 6 is just a constant, so constant multiple, so just put the 6 in front. Alright, so we have to take the derivative, so you're going to use the power rule, so put 1/2 in front. Alright, keep the same quantity, y cubed plus 1. Right, then subtract 1 from the power, so it's going to be negative 1/2 power. Alright, then multiply by derivative of inside. So derivative of y cubed plus 1 is going to be 3y squared. But since it's a derivative with respect to x, we're going to have to multiply by dy over dx. Alright, so that's the derivative of 6 times quantity y cubed plus 1 to the 1/2 power. Alright, and the rest is kind of easy because this is just written in x, so it's a regular derivative. So it's negative 2 is just a constant multiple, put that there. Right, derivative of x to the 3/2 would be, right, so 3/2 in front, x, and subtract 1 from 3/2, so it's going to be 1/2, right? And the derivative of negative 2 is 0 since it's a constant, so that's that. I'm not going to write anything down. And derivative of 0 is still 0, so you have a 0 here. Alright, then let's clean up a little bit. Alright, so you have, let's see, 2 on top and 2 on the bottom, so you can cancel those. And let's see, so there's a 2 here and a 6 there, so that's going to become 3 left over. Alright, so let's see, another thing we can do is everyone seems to have 3, so I'm going to divide it through. Alright, so I'm going to just go ahead and divide through by 3. Alright, divide through by 3. Alright, that basically means that, okay, so I can get rid of this one from the first term, and I can get rid of that from the second term. Alright, so what's left is going to be, alright, so here, so 1's 1 here, and we have y cubed plus 1 to the negative 1/2 power. So that's the same thing as 1 over, right, square root of y cubed plus 1, right? And then you have 3y, oh, actually, maybe I should put that up here. Alright, so there's going to be 3y, so I took care of this. And there's a 3y squared, so I'll put that up here. So 3y squared. Then we have dy over dx. So let's take care of that. So dy over dx. All right. Then actually I'm gonna go ahead and add x to the 1/2. Right. So that way we can move this term right here over to the other side. So it's negative x to the 1/2, so it goes on the other side. Becomes we're adding positive x to the 1/2, which is just the square root of x. Right? So because it's the same thing as x to the 1/2. Alright, then we just need to isolate dy over dx. This is easy enough. Alright, so we can just multiply by the reciprocal of this guy, which is square root of y cubed plus 1 over 3y squared. Alright, so dy over dx is going to be equal to, alright, square root of x times the square root of y cubed plus 1 is square root of x times y cubed plus 1. Alright, then you have to multiply by 3y squared on the bottom, so you have 3y squared. Alright, so that's the derivative that we're looking for. Alright, so from here we can find the slope. So let's say find the slope m is going to be, we have a derivative dy over dx, and we need to evaluate it at 4, 2. Right, so that comes from here. So let's do that. Alright, so plugging 4 for x, so it's a square root of, right, 4 times, alright, so plug in 2 for y, so it's going to be, can put that, it's a 2 squared, cubed, plus 1, right? Then you have 3 times y is 2 squared. Right, so what's that? So this is going to be, right, so this is 4, and 2 cubed is 8, plus 1 is 9. So 4 times 9 is 36, and divide by square root, take the square root of 36 is 6, and divided by 3, or actually, we can, oops, sorry. Alright, so it's going to be 3 times 4 is 12. So the slope is 1/2. Alright. Now we have everything we need, so therefore the equation of the tangent line would be y minus y1. y1 is right here. So it's 2. So 2 is equal to slope. We just found that to be 1/2. So we put 1/2 times quantity x minus x1. x1 is 4. Alright, so we have that. Alright, so if you want to write it in slope-intercept form, we can just distribute negative 1/2 to x. You get 1/2 x, and distribute 1/2 to negative 4. You get negative 2. Right? Then all you really have to do is get rid of this negative 2 by adding 2 to both sides, which is going to give you y is equal to, actually this cancel out too, it's simply 1/2 x. Alright, so this is the equation of the tangent line that we are looking for. Alright, that's it. I hope that this was clear.